So now, good afternoon all. Now we are starting with next session number 3, lecture 3, where we are dealing with next type of problem that can be asked for your paper university exam for 10 marks. So yesterday's session we had different cases of development of prism, pyramid. Means till date we had a discussion on all the concepts and the development we have seen with the special problem. Again today the slides change, means they are not same problem that what we had yesterday. So it's actually prism, and we'll have one more pyramid problem in today's session. So you can read the question. I hope it's readable now. This diagram is given in the question. Figure shows the front view and the top view, or even if this is not given, how you will draw the correct diagram, that we will discuss on different possible cases. So front view and the top view of hexagonal prism of base 30. So this is a hexagonal prism with the base 30, axis height 70 mm. So this is axis height of the prism, which is 70, resting on HP on the same problem, but rectangular face parallel to VP. That's additional condition. So we know that for the prism we have rectangular faces, and they mention one face should be parallel to VP. That's a condition. So we'll discuss how. Even the diagram is not given, I will draw a correct position for this condition. We'll see. It is cut by AIP as shown. What is AIP? Auxiliary inclined plane. This plane what I have drawn. Draw the development of lateral surface. So as diagram is given, they have mentioned the plane is making an angle of 60 degree, and this, as this is given, the position, this is bisecting the axis, the distance when this axis is intersect, it is a 35, so it is at the mid. So anywhere you can show this 60 degree. So basically there's a plane makes an angle 60 degree with HP and bisecting the axis. Okay, so that's a condition. If the diagram is not given, with up to this they may add as shown. They can change the statement as the cutting plane is inclined with the angle 60 degree to HP and it is bisecting the axis. So same you need to draw. So we'll discuss how you can draw and how you can start. So I'll explain first. Let me know what I am showing here on this pages, is it visible or not in the chat, so that I'll continue with the same. Or there is a problem in the focusing this. I hope it is clear. Now, to understand the concept, I'm just explaining how you need to draw this given condition. As it is given a hexagonal prism, so why I have not drawn the hexagon like this? So if I can draw hexagon like this also. Means draw a circle first. You can draw vertical diameter. From these two ends you can mark the radius from this two radius, which is equal to side of hexagon. Then you can again join all the points. You will get again the hexagon. I'm drawing this freehand sketch. So in this case and this case, what is the difference? It is mentioned a rectangular face parallel to VP. In all those cases, if you see, we have this. None of the face is parallel to VP. We want one face to be parallel to VP. So for the given problem, you cannot draw this position of hexagon. Clear? Now, similar as it is a prism problem, so it's quite, you understood the difference between the why I have drawn this position only with hexagon, keeping this horizontal reference diameter, because in that case this BC as a base edge and similar the corresponding top points means a face, as well as this EF is parallel to VP. VP means vertical plane. So this should be the position. If the even diagram is not given, you should draw this hexagonal prism resting on the corner in this position, so that you will get these two faces parallel to this XY line, means parallel to VP. In this position of hexagon, we don't have any face parallel to VP, so you cannot, means this is the wrong way. We should have the, because as it is mentioned, a rectangular face should be parallel to VP. That's why we are talking about this. So this is the first trick. If you draw this case, you'll get a 0 mark, because in that case okay, I think it's connected now. So yes, when they have mentioned one of the face of a prism is parallel to VP, then this base edge in, let's say, hexagonal pyramid, we always prefer, means we should draw this position only of hexagon like this, means by referring means you draw first circle, draw one horizontal. I'll use another page. Even for hexagonal pyramid, first draw this reference diameter, then from this position to mark the radius, from this end 2 point, from this end 2 point. Then what you get is this hexagon. Why? Because in this case it is a, if it is a pyramid, we need one edge to be parallel to this always. For the pyramid, one edge here also. I'm talking about a slant edge. So if it is a triangle, so it should be drawn like this. So pyramid will be like this. So this edge is parallel to this. So you can make same. This will represent the true length. So you can make the, we'll see, this is the second problem of today's discussion. So whenever you are referring a pyramid, try to maintain one slant edge always parallel to this position. If it is not, then we'll discuss the constructions required for corresponding problem. So I hope now it's clear. We'll move to the next session, next part, how to have a solution for this problem. Okay, so now I hope that you are clear why I have drawn this position of hexagon. This is wrong because it is mentioned one face should be parallel to VP, and we have discussed the pyramid condition as well, so that will help for both the type of problem. Okay, fine. So now we'll just discuss this problem, and here we'll focus on how to get the solution of this problem. Why it is something different? If you look at the question, it is cutting plane. It's cutting the solid as a prism. This edge, this is additional intersection, and it's not cutting this edge, which is, we can say, the D dash. If you want, you can give any notation as a dash. While it's cutting the base of the prism. So this is additional. It's something interesting how you can draw the development of this hexagonal prism when it cuts the base edge. So this is cutting this base edge as well as this top face here. So this is something additional intersection which we have not seen in the previous problem. So this intersection point and this intersection point is additional, and it is not cutting the two edges, as here you can see this A and this edge of the prism as well as this D, edge of the prism. So I'm just using a convenient way to explain this. Actually, edge should have another notation. If you want, you can give this A dash, this D dash, no problem. So this edge and this edge, this two, and the plane is not having any intersection. So we are interested now how this and this intersection of plane and the solid top and bottom face, or we say the base, how it will look into the development. So let's start. So I have just drawn this hexagon with the circle method, drawing first circle with the radius equal to the side 30, axis side 70. Take a radius, mark from this 2 point A and D, arc of same radius, join those points, axis side 70, join it. This angle is 60 degree for HP, this, but it is taken at this point because it is a intersecting the, means as you can say it is a bisecting the axis. So this is at 35 mm from the both. So let's start. So development length, this is equal to circumference. Okay, so this will be equal to, as the hexagonal is the 6 base edges, one of length is 30, so that should be, if I start from this as a reference, suppose this is my first A, so 30 mm as a radius, sorry, as you can radius, you can see this distance I'll take 30 in compass, and from this I'll mark for my reference for to complete the development. Okay, lateral development. Or directly you can attach a scale and you can measure it. So A, B, C, D, E, F, and one more, last is same, A. Okay, so first this is the development. Now I'll mark all the edges, and that is the surfaces which you can see. While drawing in the exam, make sure all those lines are faint, light shaded, and the thin. So this is the development of hexagonal prism. Okay, so you can mention this distance as 30 into 6. So this is the development. So these are the 6 faces, 1, 2, 3, 4, 5, and last 6. Height is equal to this height of the prism. Now, first, a very simple, a conventional way, you just project the points which are as it is in previous cases. So this intersection of the, what you can see here, this plane is having intersection with this prism. So this first point is for which edge? It is F, as well as this is on the B. So you can see this is B and F. So extend those points up to corresponding locations here in the development. So I'll extend up to B, and same I'll extend here. F. So I got 2 points. First is this, another is this. B, F. Okay. Next, this cutting plane cuts this edge, another, which is C and E. So take here, same. So this is C. So extend the same onto the corresponding edge E. So I got this E. Now this is conventional method which we already had, right? Now what is additional thing? We don't have A means this edge or this edge in the development, means we need not to have any intersection of this plane with the surface. Now what we need to do, there is additional thing, this point and this point. So yes, to represent a corresponding point on the development, what we need to do first, so let us consider this point I need to represent here. So I'll first take its projection in the top view and I'll check where this intersection, cutting plane and this solid is intersecting here. So I'll take first point is here. Why? We'll see. Now you can observe easily this point is intersecting two edges, base edges here in the top view, which you can easily see. The surfaces are, means this rectangular face, A, F, there's one intersection. So this is our first point and this is another point, right? So let us say I'm giving you the name 1 and this is 2. So the top face, if you extend this top face in the top view, you can see the 2 points, namely 1 and 2, and the corresponding edges of the base are what you see is actually it's this 1 is in between A and F, point number 2 is between A and B. So now you need to represent this complete edge, right? So how to draw? Very simple, as we had yesterday's similar concept. Take a distance compass from A to 2, this, which is equal to of course A to 1 as well, or you can check by of course constructions, not every time same. So take a distance A to 2 in compass, this distance, and from this A mark onto this line. So you can say now this is the 2. Of course now I need to mark this line. So this is an additional to locate this point, okay? Similarly from A, take a distance in compass from A to 1, and mark from this A. Now is there any confusion? Okay, let's check. Where is this point 2? It is between A and B. So A and B I need to mark 2 distance. Where is this point 1? It is between A and F. So A and F, mark this one. From A, I am taking distance from A. So mark from A. You can take from this F and B as well. A is common, so it's simple and easy. Again mark this. So also this is for point number 1. So 1, 2, I mark 1 and 2 corresponding edge to represent for reference. Now, how to locate the point? So this intersection which I have referred here, that is projected on, if you see this intersection, say why you are doing this construction for this 2 and 1, to locate the corresponding point on the development, right? So we'll see how it can be located in development. Similarly, if you observe this in the same fashion like this, we need to do the same procedure for the C and E. Sorry, C, and you will say another point, this. So this you should again take in projection in the top view. So when you will take its projection of this intersection of plane, this base, it will cut at 2 points. Let's say 3 and this is 4. So we have 3 and 4 another points which represent the as shown in the diagram in top view. Now same, take a distance from D to 3 and mark as it is in between D and E. So in between D and E there is a point number 3. So D3, from D I need to mark a point. Join it. So I'll say this is point number 3. Similarly, from C to D, D to C, in between this we have point number 4. So D to C we have point number 4 somewhere here. So take a distance in compass from D to 4, D to 4, that is in between C and D. Okay. So actually it was interrupted. So I'll just explain once again. This plane intersection with the top face and the bottom face base. So this point projected here to get 1 and 2. Take a distance of this 1 and 2 from A and mark from both. This is 1 in between AF, so 1 in, so no problem with notation. Take this distance, mark here from A, take this distance, mark here, have corresponding edges. Similar way, this plane cutting the base, take it the point here in the top view, it's cutting the base edges or the face as 3, 4. So that 3, 4 points from the D is transferred here, from D 3 here, 4 here. Just check CD and D. CD, D. Now you can clearly see from as it is a top face intersection here, corresponding points are 1 and 2. So this projection for this is for point 1, this is for point 2. Now base edge, this is a projection for which point? 3 and 4. So now this is 3 C, right? This intersection and 4. So I got all the points. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so why this 2 extra points? Because we have this additional 2 points. Okay, now join all those points to get development. So yes, this is what you can see after when these are the given condition when you have 30 by 70 prism, one face parallel. This is the angle, so top face is here. So yes, this is the development obtained which I have shown here by joining the lines. Only the additional thing was when the cutting plane is having an intersection with the top face and bottom face, or maybe any other one face, or if they give only solid like this, how you can obtain the development. So yes, this is the development you can see. Additional thing to note here, this A and the D, two edges, they are not cut by this plane. So this face and this face not having a part of your intersection points to locate. So logically you can locate all the points to have a development. So that's something interesting problem. We have located this additional 1, 2, 3, 4 with corresponding projection from front view. Here these are the points, and this is complete development. So this is quite sufficient to understand the problem of development of this type of, means you can have any other problem on the similar fashion. So just go through it. If any doubt in regarding this procedure, let me know in the comment section. So shall I proceed to the next problem? I think now we'll move towards a second question. We had a first. Today's discussion is based on this two topic. One was this with additional development thing, which you can see here. This can be asked for your NSEM paper for 10 marks. Give dimension here clearly as 6 into 30 as a hexagon 6 faces. Okay, so just read the question. A triangular pyramid of base side 30 mm and axis height 60 mm resting on HP on its base with one of the base edge parallel to VP, and it is cut by a cutting plane inclined at 60 degree to HP passing through the point of axis 20 mm from the base. The apex portion is removed. Draw the lateral development of a surface. So quite interesting, looks very simple, but yes, why I have taken this problem, you'll get to know once we start drawing it. So first thing which you note here is it's a problem of triangular shape is important. Triangular, now what is, not prism, it's pyramid, triangular pyramid. Dimension is simple, directly given, 30 by 60, means 30 is the base side, axis side 60, resting on HP on the base. So additional thing, this you should remember, if it is given you should follow this condition for your solution. Otherwise normally we, for pyramid we always make sure one corner is on the towards right so that we can get a two length in the front view. But now as one of the base edge is parallel to VP is mentioned, even it is a triangular pyramid. So let's see how you can draw this shape. So first I'll start with the top view. So I'll make sure you can follow the same procedure for drawing it. So it's a dimensions are very small. It's 30 mm, so very small pyramid actually. So let's draw. So what is the condition? One base edge is parallel to VP as discussed in similar previous problem. When it is mentioned base edge parallel to VP or a rectangular face for a prism parallel to VP, in that case in top view one of the base edge should be parallel to VP, that means parallel to XY, parallel to horizontal line. Clear? Now I will draw this 30. Now triangular, so of course it's equilateral triangle, that is what we are assuming. So 30 mm is this side, so you can take a 30 mm distance in compass. So I have drawn this parallel to VP. Okay, you can take this either on this side or this side, doesn't matter. Remember it's a pyramid case. You can directly so yes, this got 30. So this is 30 by 30 means it's a triangular pyramid top view. So I have drawn a triangle with 30 dimension. Now to have its front view, very careful. First we'll locate the front view. It's a trick is in the development when you're drawing actual development. So I have drawn triangle in the top view. Remember it's a pyramid, so we need to have its center to locate the axis in the front view. So how we find out a center for this? It's not a normal circle for hexagon is pentagon. What we do pentagon similar way. Let's say A, B, C. So join any two corner point with the opposite mid. So this is 30. So this, let's say this is a mid. So join this A with the mid. Join any two corner with opposite side midpoint. The intersection of these two lines will be the center. Similarly, this AC mid is somewhere is 15. So join B to this. Remember this is the center. Intersection of these two lines is the center. Now to show its pyramid, join the slant edges, out of which let's say this is O. OA, OB already joined, but remained only one side is slant edge OC. So now OC, OB, OA. So now here is the trick. In this problem, as it is pyramid, can you see any edge is parallel to XY, means parallel to VP? Can you see? No. Because it is clearly mentioned in the question, one of the base edge is parallel to VP. So we should draw this AB like this, or vice versa. We cannot have another position. I'll tell you with the rough sketch. Suppose if I draw this triangle like this, what we normally follow, keeping one corner on this side. So it will be like say O. So this is OA, OB, OC. So if you draw this position, so this is parallel, so it's easy, but this is wrong. You'll get 0 marks. Why? In question it is mentioned one of the base edge. If it is not mentioned, then it is correct. You can draw this position as well. But if it is mentioned in question that one of the base edge is parallel to VP, when these are the base edges A, B, C, one should be parallel to XY. So right now none of the edges parallel to VP. So for our convenience, what we follow is not applicable for this problem special. Now otherwise, if it is a pentagon, what we do, how we draw pentagon? We draw this line with let's say 30 we take angle 108 and then we take intersection, then that's it. So in this case also you get this edge parallel, another is they are not parallel for pyramid. So that is okay, but even in this case as well, similar to this, none of the edge is parallel to VP. So if the problem is of triangular or pentagonal pyramid, and if they mention a stream, very important condition that base edge is parallel, then these two conditions, these two ways you cannot draw. In that case, none of the edge is parallel to VP. If it is not mentioned, then they are correct. Then you need not to have any other construction which we'll have for this problem. Clear? I hope it is visible and you are following me. Now we'll go to the next part, how to get a front view. So let's start. So as conventional way, project is projection from all those points So mark axis, important. Remember, axis height is given. There may be, again, if you want to make this problem difficult, instead of axis height they can give you the slant edge length. We'll see how it is. So if you observe OA, OB, OC, none of the edge, slant edge is parallel to VP. I mean, this is not parallel to this line, XY line. Now, right now it's simple, 60 mm, so I can make directly a scale attached here. So this is 60, so this is my O point. Join it. So what you can see right now is front view. Give the notation. Suppose this is A, this is B. Now, if you see this, it's coinciding this, so this will be C. You can draw the similar fashion, same. Okay. Now, as it is coinciding, so I need to draw edge, not axis. As we discussed, it is preference of lines. Where is visible line, when to draw hidden line, and when to draw the axis. So we have A, here B, and this C. Okay. Now, in a normal problem, what we do is parallel to OA, we draw one reference each and we complete the problem. But here, this OA, what I have drawn, it's not a true length of the OA edge. This is OA, which is inclined to this line. So if I extend, I can't see its true length. So this is a very, very important construction, as none of the edge in top view is parallel. I'm talking about the slant edge, means OA, OB, OC. Therefore, we need to make any one edge to parallel to XY. So how to make? Very simple. In that I'll make OA only. So take OA as a distance in compass, or make OA parallel to XY first. So I have drawn arc, O as a center, OA as a radius. I have drawn an arc so that it can be parallel to XY. See? So parallel to XY. So now this intersection, this is horizontal line, making this OA parallel, means this OA, which is now inclined, I have drawn this as straight. Okay, means making this OA parallel. That's it. That's simple technical word you can say. Now extend this point which I have projected here by making OA parallel. Project this point in the front view. This is the true length which you should consider for reference. Now join it with the O. So the line which I have drawn right now, by making OA parallel first, take O as a center, A as a radius, mark here up to horizontal, then that point is here and join with O. This line is a true length of slant. That's why in all previous problem we need not to do all this construction, because one edge was already parallel for this. So I hope it's clear why you are doing a construction for this. Now I'll make this new point as A dash of true length, blue color. Previous was OA, which was not the true length. If you forgot to do this for this problem, then the rest of the drawing or the construction is technically wrong. So this is required only when in the top view none of the edge is parallel. So we make this side edge parallel, we project here, join with the same apex, this represent the true length. Then you follow the same procedure. I hope you are following me. If any doubt, if you left behind, let me know in the chat. Okay. Now, parallel to this line, new line, OA dash blue color, draw one reference line. I'll intentionally represent this as OA dash because that represents the true length. Rest is same. Take O to A dash as radius in compass. Mark one arc. Now this as 30. Now to draw development, take this as 30. From this A dash, mark the A, B. So this A dash represents actually the A. Okay, so this is A, B, C and A. Join it. As it is pyramid, join the base edges A, B and so on. So I am joining A, B, B, C and again the last one. Okay, so this is the 1, 2, 3 three-phase triangular pyramid. Yes, this is a very important part. If you make a mistake here, if you forgot to take this, then no use for the rest of the drawing. Okay, so first intentionally I have taken this problem today as last discussion to understand the concept of this true length. Okay, so this is the trick point to remember. It's not every time, it is only applicable if none of the edges is parallel in the top view, or when the condition is given one base edge is parallel to VP, so you should have this starting position. Otherwise we could have started with previous as I discussed. Okay, fine. Now second part of this problem is intersection, means cutting plane. It is cut by a plane inclined at 60 degree to HP. So draw a cutting plane 60 degree to HP. It passing through the point of axis. So point, this is axis. Point of axis 20 mm from the base. So first locate the point which is 20 mm from base. So from 20 mm base is this point. So this is the 20 mm. I'll mark here. This distance is 20. Why to mark? Because they are given on the axis 20 mm from base 20 mm, the plane is 60 degree to HP. Remember again, sometimes they may have a trick in this. Instead of normally we take angle with HP, they can give angle with axis as well. So carefully check the question, or maybe they can give the angle with any other reference line to locate a plane correctly. Now keep your D here on 0. Make sure that it's correctly taken angle 60 degree. This is the reference point only. Of course, you need not to draw that too big on the So if you observe while locating the plane, you will get to know this plane yes, that's a trick. Again, Once you locate the plane, then only you'll get to know. It's not that easy what you see at the start. If you see in the question, it's clearly visible the plane is cutting the base edge as well. It's not cutting the slant edges only. There may be a small difference. If you observe, this cutting plane cuts how many edges? This A, C, not of course B. Now this intersection has to be transmitted. As C, we have taken this true length for us, we have drawn already development. Now this intersection of this OA with cutting plane, one point, with the C, another point. We don't have a B, but we have this additional base to previous problem. So see, it's not that simple, but when you read a question, it looks simple. Project this point of base intersection in the top view. It cuts 2 points. One is here, A, another is this BC. So same logic. Take a distance in compass. From B, take this distance. As it is very small, I'll use only scale right now. So it is around 5 mm, 5 to 6 mm, and you're trying actually get to know. It's approximately same. So it's almost 5 to 6 mm from B, A. So I'll mark okay, from B towards A side. From B towards A side, this is 5 mm. So from B towards A side, this is, you just measure it clearly. Okay, fine. This is the point. Join it. I'll mention this. If you want, you can give notation, no issue. I'm just showing in the video clearly. From B towards A, this distance 5 mm, I have marked from B towards A, this 5. Join it, you got this H. Same. From B towards C, from B towards C, this distance is approximately, you can check in compass and mark here. From B towards C, it is something around 8 to 9 mm. I'll mark here. Again join this H. Now next is logical. This intersection, 2 points, they are transferred, as you know very clearly, on the corresponding intersection. So this intersection is on the base, so base will be this. So I got these 2 points on the base edge. So this is additional 2 point. Rest of the points are in a conventional way like previous problem. So this intersection of a plane with the A edge, this is for a C. We don't have a B because B is not intersecting by this corresponding condition of a plane. Now I'll take O as a center. First this point as in radius, so you can see in the video this distance, you can see clearly. I have taken from A, intersection of plane with A, so it is up to A. So first already I have drawn. Similarly at this point also. So yes, I got 2 points of A here and here, this 2. Then we don't have a B, no issues because B is not cutting by the plane, and C. Now take O as a center again, this distance as radius, mark up to C. So here this is C. So you got all the points, namely A, C, no B, but yes, additional this 2. Notation doesn't matter as discussed. We are just interested in the correct development concept. So you draw these points development, which will look something like this. Now, if you observe, the intersection of these points is it's basically these points of A, this. So this represent the complete development or after cutting the plane below it. So retained development will be this A, 2 points, C, this point, don't have B, but we have this base. So this. I'll say this as a 1, this as 2. That's corresponding point. You remember this 1 and 2. So yes, these are the development of this triangular pyramid. I hope it is clear. Once you draw on your own, you'll get to know all the points and the concept very clear. Just locate the points and join those in sequential. So this is for today's session. I hope it's clear with the both type of problem. Join those points together. That's it. That's a development of triangular pyramid with all the concepts of a true length and cutting by a base edge. And the previous was again the same case, but for applicable for a prism. So in next session probably we'll start with the next basic fundamentals of unit number 4, 5. That is isometric views. Let's connect soon for this session, and it will be of course communicated through the live that how we are going to proceed for the further chapters. Try to solve these problems on your own with available things, of course, but just try. If any doubt, let me know in the comment section. I'm waiting for your comments so that further actions can be taken to improve our communication for graphics. Thank you.